Extreme heat waves are affecting southern Europe, including Greece, Spain, and the UK. Temperature records effectively illustrate the severity of the heat. The intensity of the heat waves can be effectively demonstrated using visual temperature records. Wildfires rapidly spread across affected regions, demonstrating the scale of the blazes. The intensity of wildfires is visually represented through dynamic heat maps and particle simulations. Geographic data illustrates the affected areas and the speed at which the wildfires propagate. Global temperatures have been steadily increasing in recent years, as indicated by climate data. Rising global temperatures provide context for the increased frequency and intensity of extreme heat waves. Data visualizations clearly demonstrate the correlation between rising temperatures and extreme weather events. El Niño, characterized by warmer-than-average sea surface temperatures in the central and eastern tropical Pacific Ocean, influences global weather patterns. El Niño can shift the typical jet stream patterns, leading to altered temperature and precipitation distributions across Europe. The altered jet stream associated with El Niño can result in increased frequency and intensity of heat waves in certain European regions. Mass evacuations are underway due to widespread fires and extreme heat. The displacement of populations is a direct consequence of escalating environmental disasters. Evacuation efforts aim to relocate affected communities to safer zones. Firefighters face extreme conditions while battling wildfires, including intense heat and smoke. Controlling wildfires involves coordinated efforts to contain the blaze and protect surrounding areas. The risks faced by firefighters include burns, smoke inhalation, and structural collapse. Urban environments experience significant air quality degradation due to smoke and pollution. Smoke-covered cities negatively impact public health, increasing respiratory illnesses and cardiovascular diseases. Daily life is disrupted as visibility decreases and outdoor activities are limited in smoke-filled urban areas. Heat waves are extreme weather events characterized by prolonged periods of unusually high temperatures. Climate change, driven by increased greenhouse gas emissions, intensifies the frequency and severity of heat waves. The science behind heat waves involves complex interactions between atmospheric circulation, ocean temperatures, and land surface conditions. Rising CO2 levels are a primary driver of climate change, evidenced by increasing atmospheric concentrations. A direct correlation exists between increased CO2 levels and the frequency and intensity of extreme weather events. Statistical models project a continued increase in extreme weather events if CO2 emissions are not significantly reduced. Aerial footage provides a broad perspective on the devastation. Drone footage showcases the scale of the crisis. The aerial view reveals the widespread impact of the disaster. Mitigation strategies aim to reduce greenhouse gas emissions to slow climate change. Transitioning to renewable energy sources like solar and wind power is a key mitigation strategy. Carbon capture and storage technologies can prevent CO2 from entering the atmosphere. Renewable energy sources reduce dependence on fossil fuels, promoting energy independence. Transitioning to renewable energy is crucial for mitigating the effects of climate change. Solar, wind, hydro, and geothermal energy are key renewable alternatives to traditional fossil fuels. Individuals can reduce their carbon footprint by adopting sustainable practices in their daily lives. Communities can collectively lower their environmental impact through shared sustainable initiatives. Sustainable practices include reducing energy consumption, minimizing waste, and conserving resources. Adapting to extreme heat involves improving infrastructure to mitigate its effects. Heat-resistant crops are a key adaptation strategy for ensuring food security in hotter climates. Effective adaptation strategies require a combination of technological innovation and sustainable practices. Community-led initiatives can build resilience to climate change impacts in urban areas. Urban greening projects are effective strategies for enhancing community resilience. Community gardens promote local food production and reduce reliance on external resources. Recovery and rebuilding efforts are crucial in the aftermath of a disaster. Collective action plays a vital role in restoring communities and providing support to those affected. Rebuilding efforts symbolize hope and resilience in the face of adversity.